The question is to find the limit. Here we have limit as x approaches infinity, right? If we substitute infinity here and here, then that's going to be infinity minus infinity. And that's indeterminate form, right? So we're going to have to rationalize this expression before we find the value of limit. So let me erase this and rewrite this expression as a fraction form. And I'm going to multiply by square root of x squared plus 6x minus 1 plus square root of x squared minus 5x plus 2 over same expression, x squared plus 6x minus 1 plus square root x squared minus 5x plus 2. So this limit is equal to limit as x approaches infinity, this expression squared minus this expression, right? So that is equal to x squared plus 6x minus 1 minus x squared minus 5x plus 2 over square root x squared plus 6x minus 1 plus square root x squared minus 5x plus 2, right? So if we simplify the numerator, x squared goes away, 6x minus negative 5x, so that's going to be 11x, minus 1 minus plus 2, that's going to be plus 1, right? Now what we have to do is we have to factor the highest degree of the terms from the denominator, which is the square root of x squared, right? So this is equal to limit as x approaches positive infinity, 11x plus 1 over absolute value of x square root 1 plus 6 over x minus 1 over x squared plus absolute value of x square root 1 minus 5 over x plus 2 over x squared, right? This is x to the power of 1, right? So let's factor out x in the numerator. So x times 11 plus 1 over x. So far so good? Now let's simplify this. X over absolute value of x. X over absolute value of x. X over absolute value of x is equal to, when x approaches positive infinity, 1, right? So we can just cancel them out. Then this is equal to 11 plus, as x approaches infinity, 1 over x approaches 0, right? 6 over x approaches 0, 0, 0, 0, right? So 11 plus 0 over square root of 1 plus 0 minus 0 plus square root of 1 minus 0 plus 0. That's 11 over 1 plus 1. So the answer is 11 over 2, right?